all we are doing today, everybody, is we're continuing with reciprocal functions, but we're going to look at the graphs of reciprocals of quadratic functions. Consider the functions y equals f of x and its reciprocal if f of x is x squared minus 5. So, this is the original function, and this is the reciprocal function. And what we want to be able to do is sketch the graph of the reciprocal function if we know what the original graph looks like. And what we did at the beginning, where I took that line, that red line, and I took the reciprocal of all the points, that will work for anything, whether it's quadratic, whether it's trigonometric, whether it's linear, it's always going to work. So we want to sketch the graphs of each, state the domain and range of both functions, the equations of any asymptotes, and also what are any intercepts. So this is a bit of a mathematical workout. Well, first of all, let me get rid of this stuff because this was not part of the question. So first things first, do we have enough knowledge in our memory banks to be able to sketch this? Absolutely. I don't care whether you use a table of values, whether you use the concept of transformations. Hold off on sketching anything just yet, okay? Because I'm going to do some very rough sketches to point something out. You know that y equals x squared looks something like that. Ish. I didn't draw it perfect because it should be going through this point, and this point. So I didn't draw it perfect, okay? But in general, do you agree that's what x squared looks like? I hope. Well, I think I would have failed you if you don't know that's what x squared looks like. Meaning, I wouldn't give you a failing mark. I mean, I would have failed in my job. What does this minus 5 do? Well, it just shifts the whole graph down 5, which is a very valuable piece of information because it tells us that this graph of y equals x squared minus 5. Now, yesterday we had an issue with some of your grids or one of your grids not matching up with what I had up here. Can you confirm that this is the same grid as your handout? Okay, so this is an important piece of information because it tells us that the y-intercept is negative 5. Another piece of information that's very valuable are x-intercepts, but to find x-intercepts, you let y equal 0. So if I do that, I get 0 equals x squared minus 5, and that's a quadratic equation which everybody should know how to solve. I don't think you want to use the quadratic formula here. It's not factorable. Why don't we just move the 5 over and then take the square root, of course, remembering to go plus or minus 5, plus or minus root 5. So we also have x-intercepts at the square root of 5 and the negative of the square root of 5. Well, so that we can plot them, let's determine a decimal approximation on our calculator. Rounded to the nearest tenth, is that going to be 2.2 or 2.3? 2.2, thank you. So here is where negative root 5 is, and here is where positive root 5 is. You could, we could put in more points, right? I could make a little mini table of values here, and I could look at 1 for x. And if I put 1 in for x, I see that I get negative 4. And if I put negative 1 in for x, I see that I also get negative 4. So we also have these 2 points. I could put in 2 and negative 2. And you should be thinking about this as well. I'm putting in 2 for x. 2 squared is 4. 4 minus 5 is negative 1. So I'm starting to get a pretty big picture, a pretty good picture, rather, of the graph. And you know me with drawing parabolas on this vertical surface, I'm not very good at it. So I'm not going to draw this just yet. I'm just going to leave it. We know what it will look like. Why don't we put 3 in as well for x? If I put in 3, 3 squared is 9, 9 minus 5 is 4. So it is also going to go through this point and this point. That's what the parabola will look like. Now, what about the reciprocal? Well, I'm going to go back to the more kind of conceptual thing that we learned last time. If I want to graph the reciprocal of x squared minus 5, you need to, and I'm just going to give it one more crack. You need to understand that this is the same as this, isn't it? But this thing I've highlighted on the right of the screen is the y-coordinate on the red function, which means this is the reciprocal of the y-coordinate on the red function. So I don't think we need to justify that every time, but I'm trying to explain to you again that what's happening is we're going from this to that. So all we need to do is take the reciprocals of all of the y-coordinates. So for example, I'm going to start on the left. This point up here is at 4. What's the reciprocal of 4? A measly 1/4. This point right here has a y-coordinate of 0. What is the reciprocal of 0? Well, hands off. You can't do that. What that means is we are going to have an asymptote there. And we're approaching this from a lot of different angles. We could have started by saying, you know what? Any place there's an x-intercept, you're going to get a vertical asymptote. The same thing is going to occur over here. You should also know that there is a horizontal asymptote here. Now I'm kind of forced here to sketch the red function. And it may not be pretty, but again, you know me, I'm not good at drawing, particularly parabolas for some reason, on a vertical surface, but I'm going to give it a shot. It may take 1 or 2 tries. Okay? Oh, it was going so well too, wasn't it? Let's try that again. That's not bad, right? Let's see you do better. No, you try to draw. It doesn't have to be perfect. The reason why I wanted more points is because there is an invariant point right here. Because this point, this red point on the original function has a y-coordinate of 1, and the reciprocal of 1 is still 1. And now this gives me, it's the way I can describe. You know what? It's giving me some boundaries on how to graph that brown graph over here. It must look like this. It has to look like that, because it's asymptotic to both of those dotted lines. And the word asymptotic is actually a word. It means the graph is squeezing against the asymptotes wherever possible. If we do the same thing on the other side, I'm going to try to draw this. Actually, I'm going to cheat. I'm going to draw the other half of this parabola now. It was so good I didn't want to mess it up. Okay, there's the other half of the parabola. So if I take this y coordinate on the original function of 4, the reciprocal is 1/4, so it goes down here. And I want to just adjust something here. I don't know if I can move that or not, sure. And this point will be invariant because y is 1 there, which means I'm going to have a part of the new function that looks like this. Are you with me? What about the middle part? Well, I hope everybody sees that this will be invariant and this will be invariant because those y coordinates are -1, and the rule is right there on the bottom left of the screen. You take the old y coordinate and you reciprocate it to get the new y coordinate. And the reciprocal of -1 is still -1. Before you draw this, just look at what I'm drawing and ask yourself if it makes sense. The graph must do this and that if it's asymptotic. Okay? And these two curves must meet. But here's my question to you. Should I draw this, and you're not going to draw it, should I draw this? Should I draw this? Should I draw this? How should I draw it? How do I decide where it peaks? And the answer is, by peaks I mean reaches the peak. The answer is start taking some of these points and reciprocating them. This y coordinate is -5 right here. So what is the reciprocal of -5? This is why I went through this exercise at the beginning of the class. -0.2, I believe. So this point is going to be at -0.2. This is now giving me a bit of a guide here, but I'm going to take a few more. -4, I reciprocate -4 and get -1/4. Do the same thing for this final point and get -1/4. Well, now I can sketch this, right? Now I can kind of, and by the way, it's easier to sketch something if you have some points to draw it through. And what is in brown is the function. Now, we're not done. We were asked to do some other stuff. We were asked, go back and look at it, what are the domain and range of each? What are the equations of any asymptotes? And what about the intercepts? So, we have y equals x squared minus 5. We have y equals the reciprocal of x squared minus 5. The domain of this, just look at the graph. Wow, I don't even know that you need to look at the graph. You should know that any quadratic function has a domain of any real number. Since this parabola opens up, its range will be y is greater than or equal to the lowest point, which is -5. We have already determined that the x-intercepts are -√5, 0 and +√5, 0, and the y-intercept is 0, -5. Look at the graph of the reciprocal function. Look at what we drew for what I'm calling the brown graph. What is the domain of the Brown graph? Who can tell me what the domain of the Brown graph is? It's not any real number. X is not allowed to be anything. Nobody wants to take a crack at it? Come on, you guys. Ryan, do you know?
Is it anything except 2 and negative 2?
It is. Anything except 2 or negative 2. And how we're going to write that is x is not equal to 2 and x is not equal, no, 2. Where are you getting 2? Did you say 2?
Yeah, and negative 2.
No. I think I know where you're getting 2 from, but I apologize. It's not 2.
Oh, 2, square root of 5.
Root 5. Yeah, okay. You were just looking at the graph and seeing the x-intercepts were around 2, but when you look carefully at the graph, of course, they're not at 2. They're a little bit off. And you caught me too because I said yes. It's x is not equal to root 5 and negative root 5. What about the asymptotes? What are the equations of the vertical asymptotes? Well, you have vertical asymptotes at x equals negative root 5 and x equals positive root 5. Right? I mean, this should all be starting to come together in kind of a swirling, circular reasoning kind of thing, where if I'm saying x is not allowed to be root 5, then that means there is an asymptote at x equals root 5. Those are your vertical asymptotes. There's also a horizontal asymptote. And the horizontal asymptote of these functions is always the x-axis. What's the y-intercept of this function? We'll take the y-intercept of the original function and reciprocate the y-coordinate. I hope it's clear there are no x-intercepts. And lastly, the range. That's a tough one. And I really don't care too much about the range, but we're here. Let's talk about it. What is the range? It's not y as any real number, because there are values in this region here where the graph doesn't exist. It's not y cannot equal 0. It's y has to be bigger than 0 or less than whatever this y-coordinate is, which is negative 1/5. So there's that thin band in between, including the x-axis, that's off limits. So we can put here for the domain, for the range rather, y is greater than 0 and y is less than or equal to negative 1/5. Once again, I didn't write it, and I guess I could write it down, but I don't think we need to. There are no x-intercepts on the second function. Let's take a look at example 2. Sketch this graph and the reciprocal on the same set of axes. Why don't we take a little bit of a break and use our graphing calculator to help us graph this. Everything we discover about this graph on our graphing calculator, you ought to be able to figure out algebraically. For example, and just look up here for a second. If I said, what are the x-intercepts? You don't have to write this down, but I'm going to show you anyway. If I said, what are the x-intercepts, you would solve that equation. You'd multiply everything by 2. Really pretty simple. You'd factor it. And you'd say there's an x-intercept at 4 and an x-intercept at -3. You should know how to do this. I'm just saying we don't need to copy it into our notes right now. Let's graph this on our calculator. Owen, did you have a question with what I've written there?
I think it's +4 and -3.
It is +4 and -3. Thank you for catching my mistake. And never feel afraid to have that look on your face, because I watch your faces, and when I see it, I know I've done something wrong. So yes, it is +4 and -3, because 4 plus -3 gives you the +1 for the middle. Thank you. So let's sketch this on our calculator. And by the way, if you wanted to know where the vertex was, then you'd have to complete the square. I'm not going to complete the square today. I've had enough completing the square for this year. I'm at my limit. Somewhere down the road, we're going to complete the square again, so that's a bit of a lie. But y is equal to 0.5x squared plus 0.5x minus 6. We want to graph the original function, not x squared plus x minus 12. That's not the original function. I'm going to go zoom 6. X-intercept of -4 and +3. And if I want to find the vertex, I could complete the square, but I'd rather not. I'm going to be a little lazy here and find the minimum coordinates. We did this a couple of units ago. Put my cursor to the left and then to the right. Okay, -1/2, comma, -6.125. So what does this look like? It has an x-intercept of -4, an x-intercept of +3, a y-intercept of -6. And just to do a bit of review here, you should know that the vertex is at x equals -1/2, because -1/2 is halfway between these two x-intercepts. Right? There has to be, don't draw this line in, but going back to the previous units on and topics on quadratic functions, the axis of symmetry has to be halfway between those two x-intercepts. Anyway, that's what the graph looks like. And if we wanted more information, and why not? Why not? Why not go to our table, start at -4, no, start at -5, and go up by 1, and go to our table, and now I've got some ordered pairs that I can plot to give more information in the picture. So -5, comma 4, well, that's off the grid. I can't see up to 4. -3, -3, well, that's a nice point. And I hope you understand that in everything we've done today, I've used red for the original, and for some reason I'm using brown for the original here. You're smart and young, you can adapt. Okay. At -2, it's -5. At -1, it's -6. And then it's back up to -5. No, 0, -6, and it's back up to -5. And when I put in 2, it's -3. This is what the original function looks like. Just want to check something out here. So what will the new function? So brown for original. New function, I'll go green for the reciprocal? Well, the new function is going to have 3 asymptotes. I apologize for the, I'll use this color, that's better. It's going to have a vertical asymptote here. It's going to have a vertical asymptote here. It's going to have a horizontal asymptote here. It's going to have this shape in here. Just don't draw this, I just want to indicate it. It's going to have this general shape in here, but if you want more detail, when we were at -5, do you see the y coordinate was 4? So the reciprocal of 4 is 1/4. And I hope everybody sees that this original graph is going to go up through here, and it will have a y coordinate of 1 somewhere, and the reciprocal of 1 is still 1. So now we can kind of get a better picture of what it looks like. I don't think we need to repeat the process over here. It's going to look something like that. In here, in between, this will be a point, and this will be a point. How are we going to decide where it peaks to? Does it peak to here? Does it peak to here, to here? Where does it peak? We're going to take, we're going to take that y coordinate of the lowest point, reciprocate it to get the y coordinate of the highest point. That lowest point was -6.125. Thank you. It's going to be pretty tiny. 1 divided by -6.125 gives me like -0.16. So I'm even apprehensive about drawing this, because you see, I've got to draw this curve so it's asymptotic to those vertical asymptotes through those invariant points. It's pretty thin, isn't it? Like it just, whoops. I wouldn't, if I were you, I wouldn't draw anything lower than what I've just drawn. Like don't try to draw it all the way along the asymptote. You're just putting a little arrow there to indicate it goes in that direction. And then you can do that. I'm thinking you're getting the right idea, so we're not going to do domain, range, all of those asymptotes. All of the equations, all that stuff. You could figure it out. It's identical to the previous question. Let's try one final question. The graph of a reciprocal of a quadratic function has 2 vertical asymptotes at -3 and 4, and the y-intercept of the reciprocal is -1/12. What's the equation of the quadratic function? So, it turns out this is a pretty simple question when you look at it in the right way, but it can be complicated if I change the question slightly. Can somebody tell me, this is all about the reciprocal, right? All of this is about the reciprocal function. It's about y equals 1 over ax squared plus bx plus c. Can somebody tell me something, anything, about the graph of the original function before it was reciprocated? Anything at all? Any intercepts, any information at all? Claire?
The x-intercepts are going to be the same as the vertical asymptotes.
Right, the x-intercepts are the same as the vertical asymptotes. Because, and just to look at this, if an x-intercept is -3, 0, and we apply that kind of what I call a mapping rule, and we reciprocate y to find out what the new point is going to be, we get slapped on the hand because you can't take the reciprocal of 0. And this goes full circle back to the idea that x-intercepts on an original function turn into vertical asymptotes on the reciprocal. So we know there's an x-intercept of -3, 0, and we know there's an x-intercept of +4, 0. Do we know anything else about the original function? Well, we do, and this is something we haven't dwelled on. I'm going to approach it in a slightly different way than I've talked about this before, but we know that if -3 is an x-intercept, this is a Math 30 idea actually, if -3 is an x-intercept, x plus 3 must be a factor. Why? Well, let's put both of these factors together. If I said to you that this is a function that's quadratic, and I said, what are the x-intercepts? You would change y to 0. And if you changed y to 0, and you solve this, you're going to say, well, x plus 3 equals 0. Oh, x is -3. This is just working backwards. This thing that I'm about to repeat is crucial in Math 30. That an x-intercept of a function will produce a factor of that function whose 0 is the x-intercept. An x-intercept of 4 produces this factor of x minus 4 because the 0 of x minus 4 is 4. The value of x that makes it 0 is 4. Now, is this necessarily the answer to the question? And the answer is no. Can you agree that this function I've written has an x-intercept of -3 and an x-intercept of 4? Okay. Let me ask you a question. And again, I'm taking this opportunity to lead up to Math 30 type stuff. What would the x-intercepts of this function be? Well, they would be the same thing. What would the x-intercepts of this function be? Well, they would be the same thing. So as it stands right now, there's an infinite number. And if you don't believe me, look. You shouldn't need to do this. But if I graph y equals x plus 3, x minus 4, zoom standard. If you remember this next year, it's going to be helpful. Do you agree it's the right x-intercepts? Okay. If I graph y equals negative, I'm going to go -0.8, bracket, x plus 3, end bracket, bracket, x minus 4. Yes? I could change that to 0.18 x plus 3 x minus 4. They all have those same x-intercepts. Changing the value of a, which is all that I'm really doing, it's a little more complicated than that, and we'll get to that in Math 30, but basically changing the number that's out in front here, I'm just reflecting the thing up and down and making it taller or narrower, but I'm not changing the intercepts. Now I have the question for you. Why is this, in fact, the correct answer to this question? You've got it.
Does the y-intercept for the reciprocal function is -1/12? So you take the reciprocal of that, you get -12. And since the c value in the ax squared plus bx plus c is the y-intercept, 3 times -4 is -12.
Perfect. Excellent. Let's unpack that for everybody. The y-intercept, it never really said, oh, it does say the y-intercept, but because x is 0, this must be the y-intercept. This is on the new function, the reciprocal. On the original, it would be 0, comma, negative 12, because it's the y coordinate that gets reciprocated. And I don't know, when you did that, Owen, in your head, did you just reciprocate negative 112? Okay. Some people might say, what number would I reciprocate to get negative 112? But you're going to get negative 12 regardless. So the y-intercept of the function we are after has to be negative 12. And what Owen has said is, he remembers that when you expand things out, that this is the y-intercept. And he's just looked up here and said, well, 3 times negative 4 would give you the negative 12. So expanding this out, we get y equals x squared minus x minus 12. Sorry, I got a little sidetracked because that was very similar to the one in the previous question where I had them factored backwards. Remember that? Okay. This is the answer to the question at the bottom. Either what's in the green rectangle or what's in the brown rectangle. I just want to finish off with one comment. And this is, I think this is a fair Math 20 question, even though it's kind of a Math 30 idea. What if I told you that the reciprocal function had a y-intercept of that? Better not do that to you. What if I told you that this is the y-intercept of the reciprocal function? We're done. You're not writing down anything else. I don't want you to change your work. That would mean, that's the reciprocal, that on the original, the y-intercept would have to be 0, comma, negative 6, correct? Is the y-intercept of our answer negative 6? No. How would we make it negative 6? And you can't just put negative 6 here instead of negative 12 because then it won't factor into those right factors. Any idea what you would do to make that y-intercept negative 6? You'd put a 1/2 in front. You'd multiply the whole thing by a half. Which would mean this would be a half, this would be negative a half, and this would be negative 6. I just throw that out because next year you're going to see stuff like that. But next year it's not just quadratic, it's cubic, degree 3, degree 4, degree 5, etc. So hopefully that second lesson really helped you out with reciprocal functions. Here are the details, and this is true whether it's linear or quadratic or anything. You can see the assignment, page 403, 1 to 10. I would suspect that many of those questions were assigned yesterday because they were about linear functions. What I'm saying is do the quadratic ones now. And as always, I don't think you really need to graph them unless you want to.